Today's lesson, we're going to be looking at atom economy, and we will compare the difference between atom economy and percentage yield. Excuse me. There are two formulae for atom economy. I prefer this second one here. So here it says mass of product over total mass of reactants. You can also do mass of the desired product. So this is the product that they tell you in the question, over total mass of all products. Times 100. Now, the reason both formulae work is because of the conservation of mass principle. So the total mass of reactants equals the total mass of products. So this denominator will be the same as this denominator. It will have to add up to the same thing. Now, the reason I prefer this formula is that if you've already found one of the products, then you just have to repeat that down here and add the other products. So it lowers your chance of error. That's all. But you can use either formula. The percentage yield formula, however, was the mass of the product obtained over the theoretical maximum mass of product. Percentage yield took into account moles, okay? It takes into account molar quantities, whereas atom economy doesn't. Atom economy simply looks at the waste of the reaction. It's a measure of waste. So the bigger the atom economy, the lower the waste. The lower the atom economy, the more the waste of the atoms. So it basically only looks at the MR of the molecules or compounds or the air of the elements. It only looks at the atoms, a measure of waste. So let's just see what that actually means in practice first. Let me show you an example of how to calculate it. This worksheet says method 1 and method 2. That's just referring to the fact that you can use either of the two atom economy formulae I showed you. I'm just going to stick with 1. There's no point for me to do 2. It's going to give the same answer. So I'm going to stick with 1 method. You don't need to use 2 methods. So for this one, it says calculate the atom economy for hydrogen. Well, hydrogen is here. Hydrogen is 2 times 1 over all the products. So 2 times 1 is 2 plus carbon dioxide. Carbon is 12 and oxygen is 16. 16 times 2 is 32 times 100. Okay, and that's going to give me 2 over 46 times 100. And then that will give me a final answer. 1 second. 4.3%. Now, this bit is important. So far, I've always told you do not look at the big numbers, but when you do atom economy, it's the only time that you need the big numbers, which means this big numbers in front, and the little numbers all combined together. So when you find the atom economy of hydrogen here, it will be 4 times, and then it's 2 times 1 is 2. So 4 times 2 is 8. Or you could do 8 times 1, whatever you like, but you need to include the 4. Over 8 plus, so all the products, 12 plus 32 times 100, which will equal 8 over 52 times 100. And that will give me an answer of 15.4%. Now, actually, by method 1 and method 2, I think what they meant is which method is better at producing hydrogen. So if you compare these two, you would say that the second method has less waste. And so therefore, it might be preferred. But there is other things that you need to take into account, such as any toxic chemicals, what kind of materials are being used, if you're really looking at the full aspect of the question. So when it says identify other factors that should be considered to choose a method, I would learn the following. I would learn these. So to look which reaction is better, you would need to look at the percentage yield as well, because that will tell you the efficiency in terms of yield, efficiency in terms of moles. You need to look at the rate of reaction, how much the reactants cost, how much energy is used in the reaction, so is there a high temperature, what's the total environmental impact, are we using toxic chemicals, are we producing toxic gases, are we producing greenhouse gases, is the equation reversible, because that would lower your yield. So I've just done 2 examples of atom economy. Remember to include the big numbers in front. Now, if you need to practice the rest of the sheet, but if we just have a slightly more discussion on comparing the two, just to make sure it's clear in your heads. If we look at a few examples here, let's have a look. This reaction has only one product. So therefore, it will have an atom economy of 100% because all the atoms at the start are converted to products. Let's look at another example, this one here. So methane plus oxygen makes water and CO2. If we're to find atom economy, remember, for say producing water, we would do, the big 2 is included, the water is 18 in total. So it's 2 times 18 is 36. That would be your numerator. Now the denominator, in this method, they've chosen to do all the reactants. So they've added all these up. I would just add all these up instead. So I would do 36, which I already worked out, plus 44. Because carbon dioxide, 16 times 2 plus 12 is 44. And now you can see how 36 plus 44 is 80. So as you can see, it's giving you the same answer. Now, the atom economy, therefore, is 45%. However, if we look at the percentage yield, let's look at the percentage yield. Where is the percentage? Okay. So here we go. So this was the percentage yield here. So they used 32 grams of methane. How much was the percentage yield to produce 66 grams of water? So they've done all the calculations for you, but the important thing is they got 92% roughly. So as you can see, the atom economy was only kind of half of the percentage yield. So the percentage yield and atom economy are different things. In conclusion, the atom economy just looks at the waste atoms, so it looks at the amount of waste by comparing what atoms are converted to product, whereas percentage yield looks at the moles of the reaction and the stoichiometry of the reaction. Okay, so mainly the moles. Percentage yield looks at, if you like, the efficiency in terms of moles, whereas atom economy would look at the efficiency in terms of atoms being converted. So one is moles, one is atoms. Okay. Next lesson, we will be covering most likely gas calculations or limiting reactants. So I will see you then.